In this video, we're going to find equivalent expressions for equalities and inequalities. Being able to find equivalent expressions is key when solving equations and inequalities. Equivalent expressions appear different, but are in fact equal. What this means is that if you solve the expression, or if you have a variable that you plug a number into, both answers will be the same. Here are a few examples. If you have -2 plus 4, we could rewrite this. Recall that a negative and a minus mean the same thing. So as long as the signs are the same on both expressions, then they are equal. So we could rewrite -2 plus 4 to equal 4 minus 2. We could solve these and see that they are in fact equal. -2 plus 4 is 2. And 4 minus 2 is also 2. If you notice, we have a -2 and a -2. And then the 4 is positive, and the 4 is positive. The two expressions are equal. Another example is 3/4 and 0.75. A fraction is the same as division. If you take 3 divided by 4, you would get 0.75. Also, think about this in terms of money. A quarter is worth 25 cents. You have 3 out of the 4 quarters, so you would have 75 cents. When thinking about equivalent expressions, we also have the distributive property. Here's an example. If you distribute, 3 times x is 3x, and 3 times 1 is +3. You can also tell if they are equivalent if you plug a number in. If I say that x was equal to 2, I could plug a 2 in for x. 2 plus 1 is 3, and 3 times 3 is 9. 3 times 2 is 6, and 6 plus 3 is 9. 9 equals 9. Pause the video and rewrite the following so that they appear different but are still equal. Now let's see how you did. On this first one, you could rewrite this by switching around the 3 and the -5. The 3 is positive, so we can write a +3, and a negative sign and a minus sign mean the same thing, so we can make this a -5. -5 plus 3 is the same as 3 minus 5. Both get us a -2 for an answer. On the middle one, we could take 1 divided by 5, or we can find an equivalent fraction to tenths. 5 times 2 get us 10, so 1 times 2 is 2. That's read as 2/10. You could also write 2/10 as a decimal. So these two are equivalent. And then finally, on this last one, you could use the distributive property to multiply 2 times x, which is 2x, and 2 times -5, which is -10.